Most beginners build Power Automate flows expecting everything to go right. But in the real world, APIs fail, connections expire, and users absolutely will ignore your approval emails. If a SharePoint list hits a data limit, or a manager takes 3 days to click approve and times out the system, a basic flow simply crashes in the background. Nobody knows it broke until someone complains. Professional flows expect external systems to fail, using nested safeguards to ensure the business process continues even when a connection drops. Today, we will take your basic flow and upgrade it into an enterprise-grade solution. We'll implement the Try-Catch-Finally framework, set up automated IT alerts, and deploy advanced approval routing. To follow along, open up one of your existing simple flows in edit mode right now, because learning how to properly handle errors is the exact dividing line between a Power Automate hobbyist and a professional developer. Let's get started. We'll start with the most critical tool for error handling, scope actions. Think of scopes as containers that let you group related flow actions together. This infographic breaks down the industry standard for using them, the Try-Catch-Finally framework. The first container is the try block. This is where your main, everyday business process lives. It's the sequence of actions you want to happen when everything goes perfectly. Right below that is the catch block. This is your safety net. The actions inside this container stay dormant and only activate if something inside the try block fails. The last container is the finally block. This holds your mandatory cleanup steps, like closing out logs or updating a status. It runs no matter what, whether the flow succeeded or failed. Back in your flow editor, click Add an Action. Search for Scope and add 3 of them to your canvas. Rename them exactly to Try, Catch, and Finally. Next, drag your entire existing business logic, all those steps you built previously, directly inside the new try container. Your flow is now visually organized, but it is still vulnerable. To make these containers actually work as a safety net, we have to define the logical rules connecting them. That brings us to Configure Run After. This is the single most important setting in Power Automate for error handling. If you skip this configuration, your catch block will trigger every single time the flow runs, even when your try block is perfectly successful. To fix this, click the 3-dot menu on your catch scope and select Configure Run After. Uncheck is successful, and instead select Has Failed, is skipped, and has timed out. Pay close attention to this setting. Understanding how to configure run after behavior is frequently tested in technical job interviews for Power Platform roles. By checking those 3 boxes, you transform a rigid script into a reactive program that knows exactly how to pivot when an action fails. Now let's build the safety net itself. Open up your catch block and add a communication action, like post a message in Teams or send an email in Outlook. Configure this message to route directly to your IT support channel. Include dynamic content, like the flow run URL, so your team gets an immediate alert with the exact details the moment a failure occurs. With our safety net active, let's look back at the try block. The most common reason a flow drops into that catch block in the first place is a poorly designed approval routing process that times out. To prevent timeouts, you have to choose the correct approval model for your specific business scenario. This panel outlines the standard options. For example, First Response Wins is ideal for a fast-moving IT service desk, where any available agent can approve a ticket. But if you are handling travel requests, you need a sequential approval model, routing the request systematically from the employee to their manager and then up to the department head. Designing your process with the right approval architecture prevents bottlenecks, which drastically reduces the timeouts that trigger your catch block in the first place. Building a resilient flow is step 1, but professional developers don't just deploy a solution and walk away. They actively monitor it. Navigate back out to your flow's main details page. Locate the top menu to locate your run history and analytics dashboards. When an IT alert comes in, your troubleshooting process starts here. You click into the failed run history, locate the exact action with a red exclamation mark, and read the raw error logs to isolate the root cause. In an interview, being able to explain how you analyze these metrics to identify recurring failure patterns across an organization demonstrates the strategic mindset needed to oversee complex, high-volume environments. This brings us to the ultimate rule of enterprise automation. A flow you cannot monitor and easily troubleshoot is a flow you cannot trust. Let's review what you've accomplished. You started with a fragile string of basic actions. Today, you rebuilt it into an enterprise-ready solution. Your flow now catches timeouts safely and automatically fires an alert to IT the moment a connector fails, all without disrupting the business. Now that you have the fundamentals of error handling down, you are ready for the next level. In Power Automate 201, we will explore enterprise architecture, covering environment strategies, governance, and security at scale. If you are serious about mastering the Power Platform, subscribe to the channel so you don't miss the 201 series. Until next time, keep automating.